again. The next question on the paper was question 4, which again was still in the whole polynomial section, and we are solving the simultaneous equations. Now, the easiest way to do it, or the way that you want to do this, is whichever of your equations it's easiest to do it with, you want to write it so that either x equals or y equals. Because that way you can eliminate one of the variables. And if you look through the past papers, actually it's amazing how many times they are kind to you and they give you a question where either one of the variables is already isolated. So straight away we look at this and we spot that there we have a y equals there. Now it is more usual to be able to isolate the variable to get it from the linear equation, if you've got a linear and a quadratic, as we've got here, which would be that equation. But in this case, it's that one that we're going to use. And then we take ourselves to have a sandwich at a national chain of fast food sandwich emporiums. We sub y to Joe. Somebody laughed. Right, so we're going to substitute y in the second equation and get 10x plus 2 times y, but we now know that y is 2x squared minus 3x minus 5. And then we've got a plus 11, and that whole thing is equal to 0. So we need to tidy up. We expect that this is going to leave us with a quadratic equation to solve eventually. I'll take a couple of lines out of this. 10x plus 4x squared minus 6x minus 10 plus 11. We just talked about being really careful with negative signs and not losing anything and not making any mistakes. It's so common how many people make mistakes. There's one of my upper 6 students at the moment is really very good, but makes mistake after mistake in exam papers, and we've got to be really attention to detail, really careful with things. 4x squared, what have we got? 10x minus 6. Having said all that, I'm bound to make a mistake now. Minus 10 plus 11 is going to give us a plus 1. So that's the quadratic that we're left with. It probably for 5 marks is going to factorise. I think it would be too difficult if it didn't. And we can do it however we want to. Because there's only a 1 at the end, it's actually not that difficult a thing to factorise, is it? You could probably go straight into doing it. If we're going to do that method that we talked about a few minutes ago, then we would do 4x squared times 1 gives us 4x squared. Can we think of 2 things that add to 4 and, multiply to give 4 and add to give minus 2? No, I'm saying it completely wrong. Add to
plus 4.
Multiply to give plus 4x, yeah.
It isn't plus 4, so it's 4.
Sorry?
10x minus 6x is 5. It's not minus 5.
Oh, no. I wonder if I could go back and erase the bit on the video where I talk about how important it is to be careful with minus signs and to not make any mistakes. Oh, hang on, right, pretend that bit didn't happen. I did that on purpose to illustrate the problem with this. Oh no, it's the wrong colour, so it looks really obvious that I've made a mistake. Oh, you can still see it. Right, there we go. So, can we think of 2 things that multiply to give 4 and add to give 4? Crazy. Yes, 2 and 2. So that's going to be 2x and 2x. Oh no, the colours are all messed up there. This is a disaster. 4x squared plus 2x plus another 2x plus 1 is 0. Look at the first 2 terms. Common factor of 2x. 2, that's 2x plus 1 and brackets 2x plus 1. So we've ended up, oh that's a 0, ended up with a very exciting factorised thing of 2x plus 1 times 2x plus 1. Now we've gone through that quite slowly. I would hope that many of you would get straight to factorising that just straight away from there. You can see it and you put it as the two brackets. Which gives us only one solution at this point of x being minus a half. And we need to find the other value, so we need to go back and put it back into the original equation. And putting it back into, well, we could put it back into either of the equations, couldn't we? So put it back into the quadratic one. Y equals 2 times minus a half squared. Minus 3 times minus a half. Minus 5. And that gives us 2 times a quarter. Minus a half squared would be plus a quarter. Minus 3 times minus a half, so plus 3 over 2. Take away 5, and I think that's ended up being minus 3.
Yeah.
Phew. So we've got our answer as minus a half, minus 3. As the solution, it might be worth just doing a little check. Did that fit the other equation? 10x plus 2y plus 11. So 10x, that's minus 5. Plus 2 times minus 3. So minus 5 take away 6, minus 11, plus the 11 is 0. So we have got the right answer. What can you deduce from the answer to part 1 about the curve and the line? Only one mark. We only got one intersection, didn't we? We only got one solution to our simultaneous equations, which means that the line must have been a tangent to the curve. And to be honest, if you've got a question that does that, if you've got a question that says what can you deduce from the answer to part 1 about the curve and the line, well, they're not going to ask that question if there are 2 points of intersection and it's just a nice, normal pair of simultaneous equations, because they're not wanting you to deduce, well, the line just crosses the curve a couple of times, because that's not very interesting. So that second part of the question was a big hint that the first part was going to involve it being a tangent to only one route. There we go. All happy with that, in spite of the slight errors along the way. Great. Can you just pause it and then start it again, and we'll go straight into the next